in 2016, I moved from New York to the Bay Area for a job when I joined Netflix, right? And I was at the airport. And as I was going through security, the TSA agent, like, he said, hey, come here, right? And I get nervous, of course. And I go to the TSA agent, and he shows me his screen, doing like the scan or the X-ray or whatever that is, like looking into my bag. And he was like, what is that, sir? And I was just like, there's a brain-computer interface. Kind of like saying it with confidence, like it is a common thing that everyone is supposed to know about what that is. But then he said, you mean like in Stranger Things? And then that's when I lost it. I was like, yeah, like in Stranger Things. So that got me thinking, like, we've been seeing brain-computer interfaces from a long time, even from like vintage sci-fi movies about how we have these devices that they can read our minds, and we can do all sorts of stuff. And actually, we're not too far from there, right? And last year, Elon Musk announced that, he's spinning up a new company called Neuralink that, is supposed to build brain-computer interfaces to bridge the gap between human brains and computers. And also, at the same time, Facebook announced that they're also working on some projects related to that and how we communicate with computers, because the keyboard and the mouse is just not cutting it. I mean, we've been stuck with the keyboard and the mouse for a long time, and don't you wish that you could just code by just thinking about what you want to do, or maybe even more, right? And we're not quite there yet, right? We cannot just do stuff with our minds. There are some things that we can do, right? But, in the meantime, there are tons of stuff that we can do, at least related to mental health. So my name is Alex Castillo. I work for Netflix during the day, where I help Netflix get to all devices by building apps and tools that enable certification engineers and partners to basically launch Netflix SDK into many devices out there so you guys can enjoy your shows. But at night, I'm a Google developer expert on web technologies, and I just build software to try to help understand human behavior and how our brains work the way they do. That's something I'm very passionate about. So welcome to my talk. I'm going to be talking about how we can mind control the web with brain-computer interfaces, and I'm very excited about it. But before I get into any code or show you anything, I just want to really start by talking a little bit about the brain. The brain is this amazing organ that runs in around like 20 watts of power, consumes way less than any computer that you guys can have in your pockets or your smartphones, consumes around 20% of all of the energy that you intake, from all the food and those resources, and yet allows you to do amazing things. And what's going on inside our brains is that we have billions and billions of neurons that, as we are engaging with our body and sensing and just thinking, these neurons are just firing electricity. And what happens when thousands of those neurons fire electricity around each other, right, in kind of like a network type of way, that's when we get kind of like an activated neural area in our brains, depending on the type of process or thoughts that we are really that are going on inside our minds. For example, the vision, right? When we see, the vision is processed back here in the occipital lobe, and that some of those things are very important because based on the patterns and the electrical impulses from those areas, there are things that we can do to interact with the world with the help of brain-computer interfaces. So how many of you have heard about EEG or electroencephalograms? All right, around half of you. And it's very weird because most of the left raised their hands and the right didn't. But EEG is a technology that it has been around for a while. It was invented around 1929 in Germany. And the story is actually crazy. Hans Berger, the inventor of EEG, came close to a very bad accident back in the day, and it really impacted the way he was feeling at that time, while his sister was like miles away, supposedly like felt something that he could be in danger. She called for like a telegram or something, and he was like, how come she sensed that I was in danger when I really was? In his journey to figure this out, he came up with one of the most interesting things that I believe exists, which is EEG. Allows for people to allows for like brain scans and diagnosing illnesses and treating some mental disorders and many other things. And these days we actually have it accessible to consumers. So that being said, my goal and my passion is just to connect the human brain to the web browser. And as a software engineer, I just really want to use my skills for something, very meaningful and something impactful that could potentially help people. And I've just been, in the last few years, just really trying to figure it out. And I found some very cool stuff that I want to show you today. First, these are just some of the most known devices out there. We have the Emotive to the left, the Muse headband, the NeuroSky, OpenBCI, but there are tons of other devices. How many of you have heard of at least one of these devices? Okay, that's a good amount. My favorite device, one of my favorites, is really OpenBCI because it was built with open source in mind, not just in software, but also in hardware. Like you can like replace the whole firmware. You can change anything you want about that headset, and you can actually 3D print the skeleton yourself and put it together for an affordable price. It was really built and designed for people like you and me, makers, artists, designers, software engineers, and whoever wants to really get access to brainwave data. So I want to talk to you about the different inputs of EEG, or the different formats. One of them is just the raw data. Like, what is the raw data looks like? What are we dealing with here when we're talking about brainwaves? And it just, when you're looking at raw brainwaves, it looks something like this, and they just move in a time series style from like right to left. And what this means is that depending on how many sensors you have on your head, each one of those is going to represent pretty much a line. And then as the line moves up and down, that represents like positive volts or negative volts in a timeline. And that doesn't give you much, does it, right? Just wait for it. When we're talking about software and code and the data now, we're going to be getting a packet of data or a sample that looks something like this in the left. Pretty much an object with a data property that has an array. That array is going to be for each one of those values is going to be for each one of the channels, meaning each one of the sensors capturing the brainwaves from our, top of our scalp. And they're going to be coming pretty fast. Normally, you can expect at 250 hertz, and what that means is that you're going to be getting a new data packet every like 4 milliseconds. So you have to think about what are like the design patterns that can help you deal with this data and process that in real time that can help you get to accomplish what you're trying to do. On the other end of the spectrum, we have frequencies. And frequencies works very similar to the way music frequency works, right? We have hertz, and what they represent is basically how slow or how fast the wavelengths are of our brains, right? As our neurons are producing electrical impulses. And there are 5 major frequency bands or frequency ranges, and they map somehow to some cognitive states. So for example, if we start with the one at the bottom, the delta one, that goes from like 0.1 to 3 hertz, right? And whenever our brainwaves are in that range, that means that most likely we are in a kind of like dreaming state or sleeping. If we move up on the theta, it's more like going to sleep, stay drowsy. Alpha is relaxed and meditating. That one is very interesting. There's so many things that happen in that frequency range, and I'm going to show you today. Then we move to beta. It's probably the frequency of you guys in the room right now. Not you, because you're sleeping. You're probably in the delta one. But then we have gamma, which is like active thinking. So that being said, I just want to show you, let's just get this out of the way. I'm going to give you a demo. A disclaimer, they have done this before to me, so whenever someone comes here, I put the headset, they like freak out, and I freak out. So whoever comes, please don't do that. You know, I've been through that. So I'm going to need a volunteer that is going to, we're just going to look at the brainwaves. Wow, you were fast, man. Yeah, please come here. Yeah. Awesome. I never met you before. Maybe 15 minutes ago. How are you, sir? What is your name?
Zach.
Zach is here. Zach, thank you for coming. So please take a seat. And this is the OpenBCI device that I was talking about. And let me put here, get here. And it just has, this one just has 4 sensors, mostly on the side of your head and then on your forehead. And I'm going to turn it on. This has the blue light. This is wireless. There's no dongle really connecting to it. I'll explain how we're getting data from here. But I'm going to put it on your head. And I'm sorry that I probably messed up your amazing hair. I know that took some time in the morning. But let's see. Where's the other clip? There you go. Good. So I might have to adjust it based on the size, but let's put it here. Oh! If I don't say it, it happens. If I say it happens, it gets me every single time. Thank you, Zach. Jesus. Man, you have a very good head size.
Thank you.
I don't know if you have ever considered being a head model. Is that a thing?
I'll take it.
You'll take it, okay. Yeah, if you get tired of coding one day. All right, so I'm going to clip this. These are like the references. So it just basically provides a baseline for the rest of the sensors. And if something goes wrong, it just like explodes right away. But you just stay calm, okay? All right. All right, so this is an app that I built in Angular. And I have a little brain icon here that I can just click. It opens up web Bluetooth. And this is basically Chrome. So we're going to be connecting, getting data directly in the browser from this weird-looking piece of device here. So I'm just going to click on the device. I'm going to hit pair. And then there you go. These are the brainwaves of Zach in real time. Just be careful not to think anything too dirty, like, like keep it PG-13 here. And this is the time series that I was talking to you about, right? Remember when I told you the raw EEG data? This represents the electrical signal from 4 different parts of his head. And there are some things that you can do with this. For the sake of this talk, I just wanted to show you that there's a web-based app that connects to this device. You can see the brainwaves in real time. And next I'm going to be showing to you a little bit something more engaging. But for now, that would be it. I mean, try to keep relaxed, and let's see how it changes. There you go. All right. Try to blink. Blink again. Yeah, it also picks up some muscle data. So you could see some of the artifacts from like jaw clenches, blinks, and some of all the other things. Please give it up for Zach. Thank you. Awesome. And great. So that is just raw data. I use the OpenBCI Ganglion. Is that open source board that you can get. And I created a library called Ganglion BLE for Bluetooth Low Energy that you can just connect to it from the browser. It will get you going pretty fast if you're interested in just give this a try. And the API for this is very simple. You import the package. In order for you to interact with web Bluetooth as many other APIs, you have to it requires user interaction, right? For security reasons, because you don't want to just access any devices. That's why I have the little brain. So the user interaction is that click of that button, it would get you the devices, and then you can pair. But pretty much what you can do is that you could create a new instance of ganglion. And then you can do, within an async function, you can just await for it to connect and to start. And ultimately, you can subscribe to the stream of it. How many of you have used RxJS here or have heard about RxJS? So RxJS and reactive programming has proven to be the pattern that is very reliable for exactly this type of work. A stream of packets based on brainwaves at a very high sample rate. But let's just get a little closer to what you just saw in the browser. The examples that I'm going to be showing today are Angular. How many of you have done Angular 2+ here or have heard about it? All right, good. It's going to look similar to other frameworks, or it's going to just look very, hopefully, straightforward to follow along. But the basics of it is that we have a component decorator. Template represents the template of the app. So my button click here is just that little brain with some CSS. And then we have a time series component, which is what renders the data visualization. We won't get into the data visualization, but I want to dig deeper a little bit on that class here so you can see how you can pretty much get access to brainwave data from your JavaScript apps. So I show you a little bit of the Ganglion API. In this example, you're just attaching a brain because that's what we're going to be accessing. And we're creating the new instance of the Ganglion. There's another package called AEG pipes that is just a set of utilities of RxJS pipes that allow you to transform the data in different ways. Some of the ways I'm transforming the data is that I'm converting the volts to microvolts. This is a simple division. And then there's a buffer time. Think about how many times do you want to render? If we're getting packets every 4 milliseconds, is it really worth to be rendering that fast when we know that 60 frames per second will provide you with a very good, smooth data visualization? So there's some buffering involved here. In this case, it's for like a millisecond. Ultimately, we have the connect function, which is going to just connect to the headset and just start streaming. Great. So all this code that you saw is open source. You can find it on GitHub. Even the project that I show you with the time series and the data visualization. Let's jump to, remember that we talked about raw data and then frequencies. I want to move to a little bit of an experiment that I've created using frequencies. So in this example, we're going to be getting packets of data from this headset called the NeuroSky. The NeuroSky is great because it's a very low budget, very reliable, one-channel EEG consumer headset that you can buy on Amazon for like $90 or so. It's pretty cool if you want to play and start dabbling in your technology in JavaScript or even other programming languages, right? So this is the data packet. This is how it looks like. The cool thing about it is that it gives you metrics. They have this eSense set of metrics that they give you an attention and a meditation level, which is pretty cool. And then they give you just the frequency ranges in like delta, theta, low alpha, et cetera, et cetera. It gives you like signal quality. It also gives you some other things like what is the blink strength as the person is blinking. So this is my experiment here. Can we use meditation or even attention levels to make a flower bloom? Do I hear no? Do I hear yes? Yes. Who said yes first? You? All right. Let's just do it. I'm going to need another volunteer, and we're just going to go with it. Who wants to come here and make a flower bloom? There you go. Do you work at Netflix by any chance? All right. Come here, please. How are you doing, sir? What's your name?
I'm Rich.
Rich. How are you? Please sit down. This is the NeuroSky headset that I showed you. I am going to turn it on. Just another little blue light. And then this one is very small. I'm just going to put it, let's see. There There you go. Here. There you go. There you go. And then I'm just going to ground it one more time. This is a reference electrode that I was talking to you about. That looks like it's making good contact. How do you feel? Is it comfy?
No.
No? All right. He's honest. All right, so this is the app. I'm just going to real quick go ahead and start a Node app that is going to capture the data using Bluetooth. So this is not web Bluetooth, this is capturing the data via Node. So it's sitting in JavaScript land. And what this is going to do is going to take a little bit to get the full signal and a little bit longer to get it's going to create a baseline. It's going to start outputting some of the attention and meditation metrics. Right now it's at 0. And we have the signal quality right now. It's at 200, which means probably should, but here, yep. Signal quality is at, signal quality is 0, so it's supposed to, there you go. Man, don't go so fast. This is attention levels, okay? Just don't think too much. Don't think too much. You're like 100% right now. I don't know if you can see the screen right here. So just chill down. There you go. There you go. Yep. All right, so you're very good at attention. We got the point. Let's see how good you are at meditation. Not so good, huh? All right, but you're doing good. Oh. Nice. Give it up, please. Nice. You did it, man. You did it. You're pretty good at this, okay? Awesome. So that will be it for now. Thank you so much. So I want to just take this from here. Actually, let's just do a little quick experiment, okay? Because, I like people when they come here. I never said this before. I like them to struggle a little bit, But you are making this seem very easy. So what about if we do attention for... So I'm going to try to see if he can fill a glass with beer based on his attention levels. Is already full. I give up. Try to relax now. Let's see if you can unfill it. You're good, man. Yeah. You cannot even feel it. Thank you. All right. So that was our attention-based experiment on the web. And the way it happens, this is all the code I have in Node. So just check it out. We are requiring the library that connects the headset with Node. It's ThinkGear. Then we're using RxJS and getting some utility functions in this case to convert events to a stream from RxJS. From event, we have I/O from sockets. You guys are familiar with WebSockets, right? Yeah, so in this case, we're just using sockets to emit. And we create a new client, we connect to the client, and then we pass the client, and we're going to be listening in the data event from client. We're subscribed to it. So this is pretty much a callback. Each time we receive a data sample, in this case, it takes around a second. The headset buffers a little bit longer, so it can give you the metrics because it has to calculate some things over time. So every second we receive an EEG data packet that looks like what I showed you before. And then we're just sending it to via WebSockets, and that's all there is in Node. The rest of it is just UI. Let's get a little bit into what it takes to create a UI that can basically, that we can map certain cognitive states to some UI elements. And if you didn't guess it, what I used was a video player. I got a video of a time lapse of a flower blooming, and I am mapping the attention or meditation level to a certain point in time in the video. Since they never change so drastically, right? There's usually some type of a transition. You can see a very smooth animation, but I had to do a little bit of work to make the animation smooth. So this is an Angular component. I call it the Mind Video Player component. It just references a template, some CSS. The template for that app is just very simple. It's a native HTML5 video. I muted it because we don't care about sound in this case. And then whenever we're using brackets here, that means that we're binding to that property. And current time happens to be a property, the DOM for the video, which is like where Angular really, really shines. So we're basically passing a stream directly to a template and specifying that we want this to be bound to current time, which is like a little bit more, it's very semantic on the template side of things. And then the JavaScript side of thing is very light because you're basically just creating a stream. We have the playback rate. We're not really going out of the norm with the playback rate, but I'm specifying it. Then we have the source of the video, where I pass the type and the URL. The other part of the UI is the little, where it tells you the percentage and it tells you the metric. So this is pretty much very simple on a side tag. We have a color that comes from a video object or an object with some video metadata, including like what color I want to use. So it's fully configurable. We have the metric, and this syntax here, basically, we're using the pipe, the Angular pipe, and async is a native Angular pipe that takes an ArcGIS stream and binds it to the DOM. It's pretty mind-blowing, in my opinion. Great, so that's all the HTML there is for this application. The rest is just JavaScript. We start by creating a property called stream. The $sign is just really to indicate that we're talking about a stream or an observable. Just to make it very explicit, it's just semantics. But we're using the same from event utility from ArcGIS, but on the UI this time, we're passing I/O, and we're putting the socket that we are trying to listen from. Ultimately, we pass the same name of the event that we were passing from Node, so metric, :EEG. Actually, that's a typo, but yeah, you get the point. And that's one line that it's receiving. I'm using this line to get the data from the server. So that is all it takes to communicate between Node and the browser, which is, I think, pretty cool. Then we are creating a metric. We are using the same stream, but we're piping. In ArcGIS, you can do .pipe, and then you can pass operators that are called lettable or pipeable operators. In this case, map is a function that comes from ArcGIS as well, that we can do map just like a map function, but with streams. In this case, I'm just picking or plucking the EEG eSense attention from that sample that I show you. And that's my metric there. This is the last part of the code, and it's probably the most complex one, because I need to know what was the last metric that I got. And this scan operator is what allows me to do that. So in one stream, as I'm piping, I'm getting the previous and the next metric. So if, if the attention level went from 50 to 60, the previous one is 50 and the next one is 60. And what I'm doing is I'm spreading, I'm getting 60 values in between 50 and 60 that I'm going to be sending over time to create that 60 frames per second animation. And I'm using linspace for that. This is just because animation or videos, they don't provide a way for you to animate playback, right? I'm animating playback manually. And that's what I need to do, this logic that I'm like getting the two states and then creating all these values in between and then starting shooting the events every 4 milliseconds or so over 1 second of time. So the video playback is always moving. Now, I did the experiment with just a CSS and images, and I was able to do the same thing. Instead of a video, you are controlling the blur filter of an image. So if your level of attention is very high, you start sharpening the image, right? If the level of attention is not high, the image starting to get more blurry. But the cool thing is by adding one line of CSS, you know that line, the transition line, right? That can make a nice transition of that blur, filter blur. It did the whole 60 frames per second animation like so smoothly. I didn't have to do this whole dance here. But video and images, two different things, right? So that is all there is for this UI. I show you raw EEG data. I show you frequencies. I show you attention and meditation level. And that's cool, but I don't think that's just not good enough. The code for this is all open source too. You can go there. You can see exactly what I show you in a little more. You can fork the app. If you get the headset, you can just do it yourself. What's next? So I started this talk by telling you, we've seen in movies how with brain-computer interfaces, we're supposed to be like controlling things, and we're not there yet, right? We cannot quite replace the keyboard and the mouse yet. But I also told you about mental health. So what we can do in the meantime is that we can help our brains be healthier with this technology. At least that is the focus that I'm really taking on this. So I show you the huge or more flexible, bigger brain-computer interfaces that has a good amount of channels. I show you the consumer one channel that gives you some like metrics, pretty cool. And the next one is just really these glasses. The glasses that I'm wearing today are called the load and focus. Is what you see in this picture. And I put the X-ray view so you can see that it has electronics inside. So my glasses right now, they have sensors in at least 4 different parts of the glasses that they measure my brainwaves. The sensors are located around the nose here with some rubber-like material that is very conductive. And then in here, this is very flexible too. These are part of the sensors that they're capturing the brainwaves from 2 sides of my head and then up here in the nose. So if you see me wearing glasses that they don't have any lenses, I'm not trying to be cool. I'm just trying to demo something for you guys. So let's just get to it. Last weekend, I participated at a hackathon, and I put together an app in 20 hours that I'm calling the Panic Glasses. These glasses were intended to they're marketed to be used to help you increase attention and focus levels, right? And they're usually like sunglasses, so I just took out the shades part of it. So my idea was, we have this amazing wearable that you would never know. It's a brain-computer interface. It's portable. It's comfortable. It's reliable. It's wireless. It even looks, kind of decent. And why don't we just leverage that and we try to help people with panic disorders? So the project is just a kit that comes with the glasses and a mobile app that I built a week ago, and the whole idea is that a panic attack assistance app that will help you overcome panic attacks in real time and help you get back to a mental state. Any of you here have suffered from a panic attack before? All right. Anyone here having a panic attack right now that wants to help me demo this? Yeah. No, seriously though. This is close to home. Like, I have friends, and like, I think the devices that we have these days could be leveraged to do like amazing stuff and help people, and that's why I mentioned mental health, right? So thank you for raising your hand, by the way. I think that's very brave. this is an idea, and this is just me. This is my attempt to try to do something that could be useful someday. But the way it works is that we could be gathering data, right? And we could be starting to predict data of when the next panic attack could come in the future. That's kind of like the long-term view, which is not done yet. What is done yet is that if you feel like you're about to have a panic attack, you could bring up the app, and then you could start doing some exercises that, are you guys familiar with CBT, cognitive behavioral therapy? Yeah? Well, what my app does is that it takes some input from your different parts of your head, and it validates that you're doing CBT correctly. So it helps you, the app knows if you're really being successful at doing the therapy. And the therapy consists of like slowing down your breathing, saying some things out loud like stop, stop, and some other things, right? But it validates that because we do have the data for that, and we could be a little bit more proactive on doing that successfully. So what I'm going to do really is just that I'm just going to give you a demo. This is an app right now on my local. You can actually go to from an Android device, and you could, like, it works from a mobile device. It would capture the brainwaves in real time. But so you can see it here. I'm just going to go ahead and tap here. I think you can see the little green light here. It's gonna start turning on. I'm going to start the app. Very similarly to the first demo that I showed you, this is going to find the device via web Bluetooth. So this is directly in the browser, and this works in Chrome, web, and Chrome, Android. So I'm going to connect to the headset. In a few seconds, I'm going to be prompted with some exercises. These exercises are basically based on the CBT therapy that I told you about that has been proven and studied for a long time with a lot of success. So the only demo that I'm going to be showing you about the panic glasses is that, for example, here we do have I have two things. I have the start, which is like a point, a recovery point, and then we have the like recovery rate. It's like how close are you to 100%, which means how close are you to really being in a normal state. So right now, this hasn't changed, but as soon as I start some of the exercises, this could go up. And what I'm going to show you is that right now, I created for this breathe exercise, I created I hate the word algorithm. I created a function that takes the brainwaves and it goes to certain frequency ranges that are known to detect or to map to relaxation and meditation. Remember that alpha? And then from there, it just knows how relaxed you are. Similar to what we saw, but not attention, right? But what it does is that it knows. So if you start slowing down your breathing, the app will know if you start relaxing, and it would give you points, assuring you that you're getting better and assuring you that things would get well, because what I found through my research is that during that state, it's just like very, very difficult to know that there's like a light at the end of the tunnel. And then that would also increase your recovery rate. So I'm going to go ahead, do breathe, and I'm going to start with these are the brainwaves in real time from my glasses right now. I've demoed this in the Android device, web, Chrome. So I want to start relaxing, and these two numbers should start going up. I should start getting points. It actually vibrates your device, so it gives you that physical reassurance, and it gives you a little beep too, a little sound. So I'm just going to relax here. There you go. That's when it was detected. So that is the Panic Glasses Kit. That's the Panic app that I put together just to try to help with the issue. All right, so I just gave you a demo of this. So remember when I told you my goal and my passion is just to really connect the human brain with the web. I think I show you at least 2 different ways that that can be done. I also put all the code out there. The NeuroTech community is picking up. I told you about how Facebook and Elon Musk is getting into this industry. I think this is the future. And I think getting access to, to our true selves is both scary and exciting because there has to be some ethics and some security, of course. But ultimately, the fact that we're here with some JavaScript, I have no background in medicine. I have no background in science. I think it's pretty cool that we can do this today with the tools that we have available. And you guys as software engineers or whatever your background is, the fact that you could take with a few lines of coding, start experimenting and seeing how you could either have fun or help or whatever it is, I think that's pretty amazing. So that's what I want to leave you with today. So thank you. Any questions? How far to sending instructions? We have sent instructions in different ways. One is called the P300. Turns out whenever you're focusing on something, let's say on a screen, that's kind of like flashing a little bit or you're focused, 3 milliseconds after that happens, there's an artifact, so a little intent detected. So people that have no way to move their limbs or whatever, that are in like wheelchairs, are able to move wheelchairs, and they're able to basically spell out words based on this P300 method. It's not too fast. I think the fastest is like 22 words per second or something, but it's just amazing that it's possible. That's one way. There is SSVEP, which is similar. Once you start seeing different lights flashing at different frequencies, I mean different speeds, the one that you're focused on, your brainwaves start mimicking those frequencies, and you can start, at least, you could tell which one you're focused on. And if you map those to like actions, like previous, next, stop, play, whatever it is, to do whatever you want, like that has been done too. There are some ways that you could do some training, yeah. And there's some more advanced stuff too, but these are like the ones that are like the more classical and proven that they work pretty decently. So it is possible to do certain stuff. We're not there just thinking about just like being open and just like having almost a free will just to, by thoughts, doing stuff that you want. Make me a sandwich. But you could potentially control a device, let's say the accessibility of an iPad or something that could just turn on and off your appliances and do stuff like that. So we're not there yet, but I believe because of the exponential curve that we're hitting with this, man, are gonna be, I'm just very excited about what the future has to offer, yeah. Yeah. Any other questions? All right, cool. If you want to just touch it, try it out, or just check it out here, I'll just let you just play with the headset if you want. Thank you.